Imagine that you are the inspection manager at a factory that produces cricket balls. The standard weight of a cricket ball is 160 grams. But the fact of the matter is, you will hardly come across a machine that can produce identical products. There will be some variance. And it's okay, that's how the world runs, as long as the variance is within acceptable limits. Your company wants to make sure that every ball that's eligible to be sold in the market is within a range of, let's say, 4 grams from the standard weight. That's their acceptable limits. Therefore, you want to find out the minimum and maximum weight of a ball that qualifies as a good production, so that you can reject the ones that fall outside those values. It's pretty obvious that you need to subtract 4 grams from 160 grams to get the minimum weight, that is 156 grams. Similarly, you need to add 4 grams to 160 grams, and that gives you the maximum weight of a ball that you should allow to pass. But is there a way in which we could use one variable, say x, write an equation in x, solving which will give us the minimum and the maximum weight of what? Of a ball that you as a responsible manager will allow to be sold in the market that more or less adheres to the normal weight a cricket ball should have. No matter how obvious it may seem, I would like you to note the fact that the two numbers are on two sides of 160 on the number line, and they are the same distance from 160. So you go 4 to the left, you end up at the minimum weight 156. You go 4 to the right from 160, you end up at 164, which is the maximum allowed weight. So we could say our number x is such a number that's exactly 4 units away from 160 on the number line. And we could write this information down in an equation form as x minus 160, draw 2 bars around them, the x minus 160 is equal to 4. The 2 bars that you see together is called the absolute value symbol. Absolute value. I'll explain that, don't worry. And you read this as absolute value of x minus 160 is equal to 4. And what this really means is pretty easy to understand. It means that x is a number that's 4 units away from 160 on the number line. So we have 160, x is a number that's 4 units away. It can either be less or be more. So we have 2 values for x, 156 and 164. Simple. Understanding this equation in this form actually lets you solve it using the number line. And I think often it's less confusing. The number line method is less confusing than the algebraic method of solving absolute value equations. Let's look at a few more examples. Imagine you have the equation absolute value of y is equal to 5. So this would mean y is 5 units away from, well, there's no from. We need a y minus something, right? And that becomes our from. So what do? Well, y is the same as y minus 0. So you can easily sneak in a 0 over here and say that y is 5 units away from 0 on the number line. So here we go. We have the number line. Here's 0. And y is such a number that you go 5 units to the left or 5 units to the right, you end up at y. So obviously y is negative 5 or positive 5 or simply 5. So there are two values for y, negative or positive 5. It's important that you understand that since we are talking about distance, how many units away is the distance, right? And distance can never be negative. Therefore, the absolute value of any number or any expression can never be negative. It can be 0 or it can be a positive number, but never negative. For example, if you think about the absolute value of, let's say, negative 7. Right. So let's say we want to find this out. What's the absolute value of negative 7? And we know that we should make it read like negative 7 is minus something, and if we don't have anything, we put a 0. So 0 becomes our from. And the question is, negative 7 is how many? This is a question mark. This is what we need to find out, right? Absolute value of negative 7. So negative 7 is how many units away from 0 on the number line. So think of the number line. Here's 0 and here's negative 7. So how many units is that? It's not negative 7 units. It's only 7 units. It's the distance between 0 and negative 7. And that's always a non-negative number. So the absolute value of negative 7 is 7. So we have a 7 here. It may seem pretty obvious from the two equations we solved that the absolute value equation, when solved, will always give you two answers. Is it really so? Let's think about the equation absolute value of, let's say, p minus 6 is equal to 0. So interpreting this equation in our own way, p is 0 units away from 6 on the number line. So which number is 0 units away from 6? It's the number 6 itself, right? Therefore, there's only one answer to this equation. So what matters is what you have over here. If this is a negative number, there's no solution because absolute value, as I said, can never be negative. Absolute value of something is negative, impossible. If you have a 0 over here, there's only one answer. And if you have a positive number, there are two answers, like in this equation and the previous one we solved. Let's try absolute value of 2n minus 3 is equal to 5. So n is a number, you multiply that number with 2 and that result is 2 times n, and that is 5 units away on the number line from 3. So here you go. You have the number 3. You go 5 to the left. Where do you end up? 3 minus 5 is, that's right, negative 2. And you go 5 to the right. 3 plus 5 is 8. So you have 2n is equal to negative 2 or n is equal to negative 1. You divide both sides with 2. You get n is equal to negative 1. Or on the other side, this is also 2n, remember. So 2n this time is equal to 8. You divide both sides with 2. You get n is equal to 4. That's how you could use the number line to solve absolute value equations, which in my opinion is often less complicated than the algebraic method. Before I let you go, here's some food for thought. Can you solve the absolute value equation? Absolute value of x plus 2 is equal to, let's say, 10 using the number line method. And when you find your answer to x, don't forget to plug that back into this equation to find out if you got it right or wrong.